one for previous thing and then we'll go for compound microscope. Suppose this is the eye. In order to magnify an object, if we use only one lens, then that is called a simple microscope. So the distance between eye and the lens is so small. If object is kept at distance, let us say u, because it is eyepiece, we call it ue. It is h. Angle subtended here is this theta. So the magnification produced is given by the relation d by ue. If you choose ue equal to the principal focus Fe and final image Ve is formed at infinity, magnification in this case, because ue equal to Fe, magnification is d by Fe. If you choose ue equal to Fe into d divided by focal length of the eyepiece plus d, then final image Ve is formed at near point itself. Near point here, least distance for clear vision. In that case, magnification is d by ue must be substituted, which is Fe into d divided by Fe plus d. This goes up, so it is Fe plus d by Fe, which is 1 plus d by Fe. So the range, this magnification in case of normal adjustment happens to be d plus Fe. Magnification in case of near point adjustment, it is 1 plus d by Fe. So ue for near point adjustment is Fe into d divided by Fe plus d. ue for normal adjustment is Fe. Okay, near normal adjustment means final image must be formed at infinity. Near point adjustment means final image must be formed at least distance for clear vision or near point. Okay, so say the usage of single lens to magnify objects is called simple microscope. The range of the magnification is from d by Fe to 1 plus d by Fe. What is a compound microscope? Suppose I use two lenses. Suppose this is one lens and I am having an object here. So what this lens will do, the lens will magnify, it will form the image of the object here. So this is object and this is the image formed by the lens close to object. That's why this is called objective. So the lens will form the image of the object from here to here. So because object is here, lens is formed, image is formed on the other side. This image is a real image. Real image and inverted also. And this lens will produce a magnification. Magnification produced by a lens is V by U. Since it is an objective, let me call this distance is distance from the objective. So U naught, this is the distance from the objective, image distance from the objective, V naught. Then here we use a lens which is eyepiece. So this lens forms the image here and from here we are seeing the object. Now the final image, this angle formed, there are two possibilities which we already discussed. So the magnification is to be produced by the lens close to eye, which we call eyepiece. So the magnification produced by the eyepiece, there are range of magnifications we discussed. So the magnification produced by the eyepiece is d by ue. This ue could be Fe, so that final image is formed at infinity. Ue could be Fe into d divided by Fe plus d, so that final image is formed at near point. These are things. So suppose this is a 1 centimeter object and the image is, let us say, 3 centimeter, and the eyepiece produces a final image of, let us say, I'll use this lens here. So final image is formed here, and this image, this is 1 centimeter, this is 3 centimeter, this is, let us say, 18 centimeter. So 1 centimeter object becomes 18 centimeter object because 1 centimeter becomes 3 centimeter by the objective. So magnification produced by the objective is 3 by 1, which is 3. And 3 centimeter objects becomes 18 centimeter. So magnification produced by the this eyepiece is 18 by 3, which becomes 6. So 6. So when you multiply 3 and 6, we are getting 18. Then 1 centimeter becomes here 18 centimeter. Hence, the magnification in case of two lenses used, which we call compound microscope. We are using two lenses to produce magnification. So magnification produced in case of a compound microscope, let me call it compound microscope, is magnification produced by the objective multiplied by magnification produced by the eyepiece. Magnification produced by the objective is V0 by U0. Magnification produced by the eyepiece is a D by UE we should use. So this UE could be FE, or this UE could be FED by FE plus D. That means magnification in case of a normal adjustment case. Normal adjustments, as we said, UE must be equal to FE. So magnification produced by compound microscope in case of normal adjustment is V0 by U0, which we cannot do anything, into D by FE. This is a magnification in case of normal adjustment. Magnification of a microscope in case of normal adjustment. Magnification in case of a microscope in near point adjustment is V0 by U0 into D by UE must be equal to FED by FE plus D. When you put FED by FE plus D, what you will get is the magnification 1 plus D by F, which we just worked out here. 1 plus, here we have worked out 1 plus D by FE. So I'm writing it as 1 plus D by FE. So these are the magnifications produced in case of a compound microscope. So again, I'll come back here. Here is a lens, here is the eyepiece, this is objective, this is eyepiece. You have object here and it forms image here, and this image for subtends final angle at the eye. So the final image is to be formed at near point from here, D. So from the eyepiece it is D. This is what near point adjustment means. For infinite adjustment means the light will travel parallel to each other. That we will discuss in a separate video. And here, if this is V0, or sorry, this distance from the object, right? This is the object, hence this is objective. This is eyepiece, and this distance, let us say U0, this is V0. From the eyepiece, this distance is actually UE. This, because this acts as an object to the eyepiece. So here the total length of the microscope is V0 plus UE. So the length of the microscope in case of normal adjustment, so length of the microscope will be V0 plus UE. For normal adjustment, final image is to be at infinity. That means VE has to be infinity. So UE must be equal to FE. So V0 plus FE. And for near point adjustment, VE must be equal to least distance for clear vision. For that, the corresponding UE distance is FE into D by FE plus D. So L will be equal to V0 plus UE has to be here, FE into D by FE plus D. So we have discussed the length of the microscope in each of the cases. Magnification in case of normal adjustment is D by Fe. Magnification in case of a near point adjustment, 1 plus d by Fe. So we have discussed magnifications and lengths of microscope.